Dear students, Kuempu University BSc 3rd semester Geometrical Optics Session 3. Myself Dr. Niranjana A.R., Assistant Professor of Physics. In this session, let us discuss cardinal points of a coaxial system of two thin lenses. Let us determine the cardinal points of an optically coaxial system by considering first that the object is at infinity, then the case of object located on the principal axis at some distance from the system. First, the object at infinity. Carefully observe the diagram. Consider an object at infinity as shown in figure 1. AB be a ray of light coming from an object situated at a very large distance so that U1 is equal to infinity. The lens L1 alone would form an image at G, but due to the presence of the lens L2, G becomes the virtual object for L2. The ray BD, instead of moving along BDG, refracts along DF2. When the ray AB is produced forward and the ray DF2 produced backward intersect at H1, the plane H1P1 normal to the axis can be considered as the plane at which the refraction occurred, and this plane is the principal plane. The focal length of the system is given by 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. The cardinal points. First one is second principal point. It is given by beta is equal to minus f2 d by delta or minus f2d by f1 plus f2 minus d or minus fd by f1. First principal point, alpha is equal to f1 d by delta or plus fd by f2. Second focal point is given by L2 f2 is equal to f into 1 minus d by f1. First focal point is given by L1 f1 is equal to minus f into 1 minus d by f2. 5 and 6 nodal points. Since the optical system is considered to be located in air, P1 and P2 are the positions of nodal points N1 and N2 respectively. Let us solve some examples relating to the topic. Example 1. A coaxial lens system placed in air has two lenses of focal lengths 3f and f separated by a distance 2f. Find the positions of the cardinal points. Solution. Here small f1 is equal to 3 capital F, f2 is equal to capital F and d is equal to 2 capital F. The formula is f is equal to f1 f2 by f1 plus f2 minus d. F is equal to 3f into f by 3f plus f minus 2f. After substituting the corresponding values, f is given by equal to 3 by 2f. Alpha is given by plus df by f2. D is 2f, small f is 3f by 2 by F2 is F. Therefore, alpha is plus 3F. Hence, the first principal point P1 is at a distance 3F to the right of the first lens, as shown in the figure. See the figure. Here the cardinal points are drawn. Let us calculate beta. Beta is equal to minus df by f1. Substituting the values, it is equal to minus 2f into 3f by 2 by 3f. It turns out to be minus f. The second principal point P2 is at a distance capital F to the left of the second lens. The first focal point F1 is at a distance 3f minus 3f by 2 is equal to 3f by 2 from the first lens, and F2 is at a distance 3f2 minus f is equal to f by 2 from the second lens. Since the medium on two sides of the lens system is the same, nodal points N1 and N2 coincide with P1 and P2. Next example. Example 2. Two thin convex lenses of focal lengths 30 cm and 10 cm are separated by a distance of 25 cm in air. Calculate the positions of the cardinal points. Solution. Given that small f1 is equal to plus 30 cm, small f2 is equal to plus 10 cm, and small d is equal to 25 cm. Here plus minus indicate the sign conventions. F is equal to f1 f2 by f1 plus f2 minus d. Substituting the values 30 cm into 10 cm by 30 cm plus 10 cm minus 25 cm, it turns out to be equal to plus 20 cm. First principal point is alpha is equal to ft by f2. It is equal to 20 cm into 25 cm by 10 cm. It turns out to be equal to plus 50 cm. Second principal point beta is given by minus fd by f1 is equal to minus 20 cm into 25 cm by 30 cm is equal to minus 16.7 cm. The first focal point, the distance f1 from the lens L1 is L1 f1 is equal to minus f1 minus d by f2 is equal to minus 20 cm into 1 minus 25 cm by 10 cm. It turns out to be equal to plus 30 cm. Second focal point, the distance f2 from the lens L2 is L2 f2 is equal to f into 1 minus d by f1 is equal to plus 20 cm into 1 minus 25 cm by 30 cm. It turns out to be equal to plus 3.3 cm. The first principal point P1 is to the right of the first lens and is at a distance of 50 cm from it. The second principal point P2 is to the left of the second lens and is at a distance of minus 16.7 cm from it. The first focal point F1 is to the right of the first lens and is at a distance of 30 cm from it. The second focal point F2 is to the right of the second lens and is at a distance of plus 3.3 cm from it. The nodal points. Since the system is situated in air, the nodal points are same as the principal points. The cardinal points are plotted in the figure. Carefully observe the figure. Another example. Example 3. A convex lens of 10 cm focal length is placed in air from a concave lens of focal length 20 cm at a distance of 5 cm. Calculate the distance between the two principal points of the combination. Solution. Given that f1 is equal to plus 10 cm, f2 is equal to minus 20 cm, and d is equal to 5 cm. The equivalent focal length of the coaxial system is given by f is equal to f1 f2 by f1 plus f2 minus d. F is equal to substituting the values 10 cm into minus 20 cm by 10 cm minus 20 cm minus 5 cm, which is equal to 13.3 cm. Alpha is equal to plus df by f2 is equal to 5 cm into 13.3 cm by minus 20 cm is equal to minus 3.32 cm. The first principal point P1 is at a distance 3.32 cm to the left of the first lens. So beta is equal to minus df by f1 is equal to 5 cm into 13.3 cm by 10 cm. It turns out to be equal to minus 6.65 cm. The second principal point P2 is at a distance of 6.65 cm to the left of the second lens. The distance between the two principal points of the combination is given by equal to beta minus alpha minus d. So substitute the calculated values here. It turns out to be equal to minus 6.65 minus of minus 3.32 minus of minus 5 centimeter, which is equal to 1.67 centimeter. References: Optics by Ajoy K. Ghatak, 6th edition, TMH Publishers. Textbook of Optics, revised edition for BSc classes as per UGC model syllabus by N. Subramaniam, Brijlal, M.N. Avadanulu, S. Chand Publishers. Optics by R. Murugeshan, S. Chand Publishers. Fundamentals of Optics by Jenkinson and White, 4th edition, TMH Publishers. Modern Optics by A.B. Gupta, Books and Allied Limited Publishers. Thank you, one and all.